Hi, my name is Swaminathan. I'm here to talk to you about how to use blockchain to make censorship more accountable. This is part of a project on censorship and publishing system that I'm working on with my advisor, Dr. Ryan Henry at the University of Calgary. So I'll illustrate what censorship is using this example over here. Alice here is a new journalist working for this news organization, and Bob is an entity that can coerce the news organization to take down content. Alice one day discovers evidence of Bob kicking puppies and wants to make this public and expose Bob for the puppy kicker that he is, and tries to publish that on her news website. However, Bob gets wind of this and coerces the news organization against their will to take down this content to prevent his reputation from being tarnished. Here, the news organization was forced against their will to take down this content and is not a willing participant in censorship. So what are we going to look at in this presentation? So we're going to talk about what censorship in publishing systems is and how we can use blockchain to induce accountability in our construction. So before I talk about the construction itself, I want to motivate censorship in publishing systems as a cryptographic analog to warrant canaries. So now we look at some protocols of Streisand. The first protocol here is the setup protocol, which is used to establish the public parameters of the system, such as public keys and such. The second protocol is the post-receipt protocol, which the client initiates when it wants to upload a file to the server. And if the server accepts to host this file, it returns a ticket which contains a commitment to hosting F, the location of F, and a timestamp of upload. Then at a later point in time, the client wishes to inquire about the status about this file that it uploaded. So now it initiates this protocol called the request response protocol, where it uses a seed to create a query for F's location and sends it to the server. The server processes the request from the client, creates a response, assigns a response, creates a signature, and sends the response along with a signature to the server, to the client. The client then verifies this response, and if it does not find any evidence of censorship, it outputs a 0. And if it finds evidence of censorship, it outputs a 1 and publishes the response, the ticket, and the seed as proof that the file was censored. Now, there are three cases that we need to talk about in this construction. So the first case is what happens if the server or the client lies about the time. Second case is what about the client lying about the server's response. And third is what happens if the server does not respond in this case at all. And as some of you might have noticed, I have not talked about blockchain here, so I'll be talking about blockchain starting on the next slide. So to answer the first question, we'll first have to consider blockchain as a public appended ledger. In our construction, we have the servers and clients that utilize our blockchain as a public appended ledger. Here, our first client finds that the file it had uploaded was censored, publishes a proof of that to the ledger. The server says it's going to remove a file because it's violating its terms of service and puts that to the ledger. That is one instance of overt censorship. And a third guy, again, says that a file that it had uploaded was censored and wants to publish proof of that. The fourth guy is just here sitting here happily without adding anything to the ledger because, well, it does not have any proof that a file was censored just as yet. So when we talk about the blockchain, we have to consider the notion of an epoch. What is an epoch? An epoch is the time the system takes to generate a new block. It can be either fixed duration or event-driven, and it's always associated with unpredictable knots. Now, considering, oh yes, sorry, I had forgotten about talking about the epoch. So to talk about the epoch, I want to also talk about the timestamp oracle. So the timestamp oracle here is an entity that keeps track of time. It advances the epoch, and it always generates a unique, random, and unpredictable value called a nonce per epoch whenever it creates a new epoch. All the servers and clients of the system talk to the timestamp oracle over here. And what they do is they can inquire about the nonce corresponding to a past epoch or it sends a request to advance the epoch. Now, how does this help against server or client lying above the time, you may ask? So we'll talk about that here. So consider this to be our blockchain with the different scenarios here. So when the file was committed to be hosted, the file was either taken down overtly or not. And then when the client discovers that the file was censored. In the first case, the server cannot, okay, so the first things first. So we just have to notice that the server or the client cannot lie about future events because the nonces are unpredictable values and therefore it's just not possible. All right, so now what happens if they lie about past events? If the servers are lying about past events, then if they give a nonce that corresponds to an epoch earlier than the file upload, then the proof of censorship that this client had published at some point is still valid. However, if they had overtly taken down this file for violation of TOS or some other reason, then and they provide a nonce that is earlier than the file revocation, then it falsely implicates the server in censorship. Now, what happens if clients lie about a past epoch? So in this case, the client needs to include the nonce for an epoch that happened after the file was uploaded, but before it was overtly censored. Suppose they are lying about an epoch that is after the file was taken down. That means their proof of censorship was just invalid because the file was indeed taken down publicly and overtly. Now, if they are lying about a past epoch by choosing a time after the overt censorship and then choosing a nonce from before the overt censorship had happened, then that's not really a problem because the server will now include the most recent nonce reply. We have to note that all the parties agree on these nonces, forming a consensus, and all these nonces are totally ordered. Now, there are a few more security guarantees and censorship and publishing systems that we have to look at. So we have selective non-executive resistance, we have existential enforceability, and extractability. Extractability is slightly out of scope of this talk because it basically tries to define censorship as the server not knowing a witness to the file it was uploaded. So we're not going to talk about that. So the other two questions that we had looked about, what happens when the client lies about the server's response? Here, existential enforceability takes care of that because it prevents any party that is not the server from replying as the server or forging a reply as a server. And what happens if the server does not respond? In this case, selective non-executive resistance renders it cryptographically infeasible for the server to identify which query corresponds to which file, and therefore they cannot distinguish that. And what if they engage in blanket non-response? Then these clients can all publish their queries onto the blockchain, and any verifier can just count the number of queries, just count the number of responses, and infer that the server has been engaging in non-response. So you may ask, what does the client add to the blockchain? The client, if the verify algorithm fails and finds that the server had engaged in censorship, then the client puts proof of that, which includes the response along with the signature of the ticket, along with the signature and the seed that the client had used to generate the query onto the blockchain. Now, what do I mean by that response being invalid or like the verified protocol failing on it? It means that the response was found to be protocol incompatible, but had a valid signature. Now, the next case is what happens when the server wants to take down something. What does it add to the blockchain? So here, the server can overtly state the reason why it's taking down the file, and some identifying signature or contents of the file onto the blockchain, along with the reason that it had taken that down. And you may ask, well, it doesn't really fight censorship here, does it? No, it doesn't, because the goal of this project is to make censorship all happen in the open, and it does not allow, aim to stifle censorship in any sense. It's just to make sure that people do know that censorship is happening. So to summarize, what you have seen so far is you have seen an overview of Streisand, our construction of the censorship evident publishing systems, and an overview of its cryptographic properties, and how we use blockchain to enforce immutability of the past and unpredictability of the future in our construction. Thank you. That concludes my presentation. I'll be happy to answer your questions and comments.